Everything you know about gravity is wrong. Not slightly wrong, catastrophically, fundamentally, reality-shatteringly wrong. Right now, as you sit there watching this video, you're not being pulled down into your chair by some invisible force reaching up from the Earth's core. That's not what's happening at all. In fact, there is no force pulling you anywhere. What's actually happening is so bizarre, so counterintuitive, that when Albert Einstein first proposed it in 1915, even he struggled to believe his own mathematics. Here's the truth that will haunt you for the rest of this video. Gravity isn't curving anything. Gravity is the curve. You're not falling down. You're falling through time. And the reason you're stuck to your chair right now isn't because Earth is pulling you. It's because Earth is bending the fabric of reality itself around you, and you're simply following the straightest possible path through that warped space-time. Your chair is what's accelerating. You're just trying to float freely, but the ground keeps rushing up to meet you. Now, before your brain completely breaks, let me show you something even more disturbing. Take a ball, drop it. You just watched it fall to the ground, right? Wrong. That ball didn't fall at all. From the ball's perspective, in its own frame of reference, it was floating perfectly still in space. It was the Earth that accelerated upward to meet it. And both perspectives are equally valid. This isn't philosophy. This is the actual physics of our universe, confirmed by thousands of experiments, GPS satellites orbiting above your head right now, and observations of distant galaxies billions of light years away. By the end of this video, you won't just understand why gravity curves. You'll realize that the question itself was backwards. The real question isn't what causes gravity to curve. It's why you ever thought space was flat in the first place. If that just made your brain hurt, good. That means you're actually thinking about this. Now, before we completely shatter your understanding of reality, do me a favor, hit that like button and subscribe, because trust me, you're going to want to revisit this video multiple times to fully absorb what we're about to discuss. And drop a comment right now telling me what country you're watching from and what time it is where you are. I'm genuinely curious how many people around the globe are having their minds blown simultaneously. Are you in Tokyo at 3 a.m.? London at noon? Los Angeles at dawn? Let me know. Because what we're about to explore transcends borders, time zones, and everything you thought you knew about the universe. Let's start with what you learned in school, because we need to understand exactly how wrong it was before we can see the truth. Isaac Newton, in 1687, published his law of universal gravitation, revolutionary for its time. He said that every object with mass attracts every other object with mass through an invisible force. The strength of this force depends on two things: how massive the objects are and how far apart they are. Specifically, the force equals the gravitational constant times the product of the two masses, divided by the square of the distance between them. F equals g times m1 times m2 divided by r squared. Simple, elegant, beautiful. And it worked. It predicted planetary orbits, explained tides, let us calculate the mass of the sun and moon. For over 200 years, this was the answer to gravity. But Newton himself knew something was deeply wrong with his theory. In his own writings, he expressed profound discomfort with the idea of action at a distance. Think about what his equation actually implies. The sun, 93 million miles away, somehow reaches across the vast emptiness of space and pulls on Earth. No mechanism, no medium, no explanation for how this force travels across that distance. The sun just knows the Earth is there and pulls on it instantaneously. If the sun suddenly vanished right now, Newton's equations suggested Earth would immediately fly off in a straight line. Instantaneous communication across 93 million miles. Newton found this philosophically repugnant. He wrote that one body may act upon another at a distance through a vacuum, without the mediation of anything else, is to me so great an absurdity that I believe no man who has any competent faculty of thinking can ever fall into it. Yet he couldn't offer an alternative. He had the math, but not the mechanism. The universe worked as if there was action at a distance, even though that seemed impossible. For over 2 centuries, physicists used Newton's equation successfully while quietly ignoring the philosophical nightmare at their core. Then came 1887, and everything changed. Albert Michelson and Edward Morley conducted what's now called the most famous failed experiment in physics. They were trying to detect the luminiferous ether, the substance scientists believed filled all of space and carried light waves, the way water carries ocean waves. They built an incredibly sensitive device called an interferometer that should have detected Earth's motion through this ether as we orbit the sun. The experiment found nothing. No ether. Light didn't need a medium to travel through. It just traveled through nothing. This result sat there like a bomb waiting to explode. If light doesn't need a medium, what does that mean about the nature of space itself? Is space just empty nothing? And if so, how does gravity work across that nothing? The answer came in 1905 when a 26-year-old patent clerk named Albert Einstein published his theory of special relativity. He proved something absolutely shocking. Space and time aren't separate things. They're woven together into a single 4-dimensional fabric called spacetime. And here's the really wild part: spacetime is malleable. It can stretch, compress, and bend. Different observers moving at different speeds literally experience different rates of time and measurements of distance. Time itself flows at different rates, depending on how fast you're moving. Think of it like this. Imagine you're watching a train pass by. Someone on the train throws a ball straight up and catches it. To them, the ball went straight up and straight down. But to you standing on the platform, that ball moved in an arc because the train was moving forward while the ball was in the air. Both perspectives are correct. Neither is more true than the other. Now replace space with spacetime and realize that the same thing happens with time itself. Someone moving very fast experiences time differently than someone standing still. Not perceptually differently, actually, measurably, physically differently. Time itself is not absolute. This was the foundation. But Einstein wasn't done. He spent the next 10 years asking himself one crucial question. If motion affects spacetime, what about gravity? What about acceleration? And in 1915, he published General Relativity and changed everything forever. Here's what Einstein realized, and this is the key insight that will unlock everything else in this video. There is no difference between gravity and acceleration. None. They are the same phenomenon. Imagine you're in an elevator in deep space, far from any planets or stars. Suddenly, the elevator starts accelerating upward at 9.8 meters per second squared, exactly the rate things fall on Earth. Inside that elevator, you would feel pressed into the floor. If you dropped the ball, it would fall to the floor. You could perform any experiment you want, and you could not tell the difference between being in that accelerating elevator and standing on Earth's surface. Not because they're similar, because they're identical. This is called the equivalence principle, and it's the most important concept in understanding gravity. Now flip it around. You're standing on Earth right now. You feel weight, right? You feel pulled down. But according to Einstein, what you're actually feeling is acceleration. The ground is accelerating upward into your feet at 9.8 meters per second squared. Wait, you're thinking, that's impossible. If the ground is accelerating upward, wouldn't we be moving faster and faster? Wouldn't Earth be expanding? And here's where your mind needs to break just a little bit to make room for the truth. Earth is accelerating upward through curved spacetime. You're not moving faster through space. You're accelerating through the geometry itself. The curvature of spacetime around Earth means that staying still requires constant acceleration. You right now are trying to follow a straight path through curved spacetime. That's what free fall is, the natural, unaccelerated motion through spacetime. Your chair is preventing you from doing that by constantly accelerating you upward. Let me give you an analogy that might help. Think of yourself standing on a sphere, let's say a giant ball. Now imagine you want to walk in, straight line on the surface of that sphere. You can't, not really, because the surface is curved. Any path you walk will eventually curve around the sphere. Now imagine you're not walking on a three-dimensional sphere, but through four-dimensional spacetime that's curved by the presence of mass. When you try to move through time in a straight line, the curvature of spacetime bends your path through space. That bending is what we call the force of gravity. But there's no force at all. There's just geometry, curved geometry. This is why gravity is universal, why it affects everything the same way, regardless of mass or composition. It's not a force acting on objects. It's the shape of reality itself. Now we need to talk about what actually causes this curve. Because mass curves spacetime is a nice phrase, but what does it actually mean? How does a chunk of matter bend the fabric of reality? This is where things get truly strange, and where we'll spend the next chunk of this video diving deep. The answer lies in something called the Einstein field equations, published in November 1915. These are 10 interrelated differential equations that describe the fundamental relationship between matter energy and the curvature of spacetime. On one side of the equation, you have geometry, the curvature of spacetime itself. On the other side, you have the stress energy tensor, which describes the density and flow of energy and momentum in spacetime. The equations say this: tell me how matter and energy are distributed in a region of space, and I'll tell you how spacetime curves in that region. Tell me how spacetime curves, and I'll tell you how matter and energy move through it. But here's what blows my mind every time I think about it. These equations don't describe gravity as a force caused by mass. They describe a self-consistent relationship where matter tells spacetime how to curve, and curved spacetime tells matter how to move. It's circular, but not viciously so. It's more like a conversation between geometry and substance. The equations are g plus g equals 8g over c to the fourth power times t. Don't worry about the symbols. What matters is understanding what this relationship means. The left side, that's the geometry of spacetime, the curvature, the shape of reality. The right side, that's matter and energy, mass, momentum, pressure, stress. These two things are equal, not similar, not proportional, equal. Geometry is matter energy expressed in the language of spacetime curvature. Think about it like this. Imagine spacetime as a rubber sheet, the classic analogy. Put a bowling ball on it, and the sheet curves. The heavier the ball, the deeper the curve. Now roll a marble near that curve. The marble doesn't go straight. It curves toward the bowling ball, following the slope created by the depression. That's gravity, right? Except this analogy is actually deeply misleading in a crucial way. And understanding why will help you grasp what's really happening. The problem with the rubber sheet analogy is that it uses gravity to explain gravity. The bowling ball sinks into the sheet because gravity pulls it down. But we're trying to explain what gravity is. We can't use it in our explanation, so forget the sheet for a moment. Instead, imagine that every piece of mass energy in the universe is simultaneously a property of spacetime and a distortion in spacetime's geometry. Mass doesn't sit in space, curving it. Mass is condensed curvature. Here's an even better way to think about it. Imagine spacetime as a field, like an electromagnetic field, but instead of describing the potential for electromagnetic force, it describes the geometry of possible paths through reality. Mass energy creates regions where the geometry becomes dense, compressed, where paths through time and space become tightly curved. Light photons with no mass follow straight paths through this geometry. But straight in curved spacetime means something different than straight and flat space. A light beam passing near the sun follows the straightest possible path through the curved spacetime near the sun. From our external perspective, the light appears to bend. But from the light's perspective, it's going perfectly straight. The geometry itself is curved. In 1919, Arthur Eddington led an expedition to observe a solar eclipse and test Einstein's prediction that light from distant stars would bend as it passed near the sun. Newton's theory predicted a small deflection. Einstein's theory predicted exactly twice that deflection. Eddington's measurements confirmed Einstein. Light was bending around the sun, not because the sun was pulling on it. Light has no mass for the sun to pull on in the Newtonian sense, but because the sun had curved spacetime itself, and light was following straight paths through that curved geometry. This observation made Einstein internationally famous overnight. But more importantly, it confirmed that spacetime is a real physical thing that can be bent by mass. Now here's where it gets really wild. If mass curves spacetime, and curved spacetime tells mass how to move, what happens when mass moves? The curvature moves with it, right? And if curvature is moving, that movement can propagate outward as a wave. Einstein predicted this in 1916, just months after publishing the field equations. He called them gravitational waves ripples in spacetime itself, traveling at the speed of light. For 100 years, these waves were a theoretical prediction with no direct evidence. Until September 14, 2015. At 5:51 a.m. Eastern Time, the LIGO detectors in Louisiana and Washington simultaneously detected a gravitational wave passing through Earth. Two black holes, each about 30 times the mass of our Sun, had spiraled into each other 1.3 billion light-years away. In their final moments before merging, they were orbiting each other thousands of times per second, creating violent distortions in spacetime that rippled outward like waves on a pond. When those waves reached Earth, they compressed and stretched spacetime itself. The LIGO detectors, each with 4-kilometer-long arms in an L shape, detected that one arm briefly became shorter while the other became longer. Then the reverse, then back again. The change in length? Less than 1/10,000th the width of a proton. They measured spacetime itself wobbling. This wasn't just a confirmation of Einstein's century-old prediction. This was direct evidence that spacetime is a tangible thing that can wave like an ocean. You are swimming in a medium that fills the universe, and that medium is geometry itself. Now pause for a second and let that sink in. The fabric of reality is not a metaphor. It's an actual, physical entity that ripples when massive objects accelerate. The universe has texture. Space and time are woven together into something that can vibrate, oscillate, and carry information. That information traveled for 1.3 billion years before passing through your body on September 14, 2015, briefly changing the distance between the atoms in your body by immeasurably small amounts. Every time you jump, you create a tiny gravitational wave rippling out into the universe. Every orbit of the moon around Earth sends gravitational waves propagating into deep space. The signal is incomprehensibly weak, far too small to ever detect from something as low mass as Earth and Moon, but it's real. You are constantly disturbing the geometry of space-time around you just by having mass and moving through space. The universe knows you exist because you curve it. Now, here's what's really going to mess with you. Remember how I said mass energy curves spacetime? Energy also includes energy of motion, pressure, and even the energy of electromagnetic fields. So light itself, pure energy, with no mass, also curves spacetime. Not as much as matter does, but it does. A sufficiently intense beam of light would curve spacetime around itself. In theory, you could have a light black hole, called a Kugelblitz, a region where light is so densely concentrated that it curves spacetime enough to trap even more light in a self-reinforcing loop. This means spacetime curves itself. Curved spacetime contains energy, the energy of the gravitational field, and that energy curves spacetime even more. The Einstein field equations are nonlinear. The curvature affects the curvature. This is why general relativity is so mathematically complex. You can't just add up contributions from different masses independently. The curvature from one mass affects how another mass curves spacetime nearby. Gravity gravitates. This is radically different from Newton's theory, where you could simply add up gravitational forces like vectors on a diagram. In Einstein's universe, the geometry itself is dynamic, self-interacting, and fundamentally nonlinear. And this is why strange things like black holes and the expanding universe are possible. Let's talk about black holes, because they're the most extreme example of curved spacetime in the universe. And understanding them will reveal something profound about the nature of gravity and curvature. A black hole isn't an object in the usual sense. It's a region of spacetime curved so severely that it becomes disconnected from the rest of the universe. Here's what I mean by that. Remember, in general relativity, objects follow the straightest possible paths through spacetime paths called geodesics. Near a black hole, spacetime is so warped that all future-directed geodesics, all possible futures for anything inside a certain radius point toward the center. This radius is called the event horizon. Once you cross it, every direction you can move in space points toward the singularity at the center. Not because there's a force pulling you, because the geometry of possible futures has become so twisted that toward the center is the only direction that exists in time. Let me try to make that less abstract. Imagine you're walking north. Any direction you walk that isn't perfectly south is at least partially north. Now imagine that north is the future and south is the past. Normally, you can walk east or west without going particularly north or south. You can move through space without necessarily moving through time at different rates. But inside a black hole's event horizon, the geometry is so warped that any movement through time, and you have no choice but to move forward through time, carries you spatially toward the singularity. The singularity isn't in space. It's in your future, as unavoidable as tomorrow. You can no more avoid hitting the singularity than you can avoid arriving at next Tuesday. This is what inescapable means in the context of a black hole. It's not that the gravity is too strong to escape. It's that escape would require traveling backwards in time. Carl Schwarzschild discovered this solution to Einstein's field equations in 1916 while serving on the Eastern Front during World War I. Incredibly, he found that if you compress any mass into a small enough radius, the spacetime curvature becomes infinite at the center and forms an event horizon at a specific radius now called the Schwarzschild radius. For Earth, that radius is about 9 millimeters. Compress all of Earth's mass into a sphere smaller than a marble, and you'd create a black hole. For the Sun, the Schwarzschild radius is about 3 kilometers. The larger the mass, the larger the radius, but density required decreases. A supermassive black hole might have an average density less than water. What makes it a black hole isn't extreme density everywhere. It's the total mass concentrated within its Schwarzschild radius. Now here's something that's going to sound impossible. From the perspective of someone falling into a black hole, nothing special happens at the event horizon. You pass through it moving at a finite speed, and space-time feels smooth and continuous. You don't hit a wall or barrier. You just cross a mathematical boundary where your possible futures become constrained. But from the perspective of someone watching you fall in from far away, they never see you cross the horizon. They see you slow down, your light redshifting, time dilating, until you appear to freeze, just at the event horizon, asymptotically approaching it forever. Both perspectives are correct. Time itself fractures at the event horizon. To you, crossing it takes a finite time. To an external observer, it takes infinite time. This is not a contradiction. It's a consequence of how severely spacetime is curved there. Different observers in different regions of curved spacetime literally experience different flows of time. Stephen Hawking, in the 1970s, discovered something even more bizarre. Using quantum field theory in curved spacetime, he showed that black holes aren't actually perfectly black. The curvature of spacetime near the event horizon creates particle-antiparticle pairs from vacuum energy. One particle falls in, the other escapes. From the outside, this looks like the black hole is emitting radiation Hawking radiation. The smaller the black hole, the faster it radiates. A black hole the mass of a mountain would evaporate in a fraction of a second in a burst of gamma rays. Larger black holes radiate more slowly. A stellar mass black hole would take longer than the current age of the universe to evaporate. But eventually, all black holes will evaporate, returning their mass energy to the universe as radiation. This means black holes have entropy. They have temperature. They obey thermodynamic laws. A region of curved spacetime behaves like a thermodynamic object with properties like heat and disorder. This has profound implications. Information that falls into a black hole appears to be destroyed when the black hole evaporates, which violates quantum mechanics' principle that information is conserved. This is the black hole information paradox, and it's still not fully resolved. The leading idea involves holography, the notion that all the information about what fell into a black hole is somehow encoded on the event horizon surface, like a hologram encoding three-dimensional information in 2 dimensions. If this is true, then our entire universe might be a holographic projection from information encoded on its cosmic horizon. Reality itself might be lower dimensional than it appears. The curvature of spacetime might be telling us that space has fewer dimensions than we experience. This is active, cutting-edge research happening right now. But let's pull back from the edge of the cosmic rabbit hole for a moment and return to our main question. What causes gravity to curve? We've seen that mass energy curves spacetime through the Einstein field equations. We've seen that this curvature tells objects how to move. We've seen that curvature can become so extreme that it creates black holes. But we haven't yet addressed the deepest question. WH, mass energy curve spacetime? What is the mechanism? And here's where I need to be honest with you. We don't fully know. General relativity describes the relationship between matter and curvature precisely, but it doesn't explain why that relationship exists. It's a classical theory. It doesn't incorporate quantum mechanics. And we know that at the smallest scales, quantum mechanics governs everything. So what we really need is a quantum theory of gravity that explains how spacetime curvature emerges from quantum processes. This is the holy grail of modern physics, quantum gravity. Right now, we have 2 incompatible descriptions of reality. General relativity describes gravity as curved spacetime and works beautifully at large scales planets, stars, galaxies, the entire universe. Quantum mechanics describes the other 3 forces: electromagnetism, the strong nuclear force, the weak nuclear force, as mediated by force-carrying particles, and works perfectly at tiny scales. But when you try to combine them, the math breaks down. When you try to treat gravity as a quantum field theory like the others, you get infinities that can't be removed. The theory predicts nonsense. This suggests we're missing something fundamental about the nature of spacetime itself. Maybe spacetime isn't continuous at the smallest scales. Maybe it's quantized, made of discrete chunks, like pixels on a screen. Maybe at the Planck scale, 10 to the negative 35 meters spacetime becomes granular, foamy, fluctuating wildly due to quantum uncertainty. Loop quantum gravity, one approach to solving this, suggests that spacetime is woven from loops of gravitational field lines, creating a network or spin foam that becomes the fabric of reality. In this view, curvature emerges from how these loops connect and interact. String theory, another approach, suggests that particles are actually tiny vibrating strings, and gravity emerges from closed loops of string. Space-time itself might be emergent, not fundamental, but arising from deeper quantum information structures called qubits of entanglement. These theories are mathematically sophisticated, but remain largely untested because we can't yet do experiments at the Planck scale where quantum gravity effects would be obvious. So after 90 minutes of deep diving into the mathematics, history, and cutting-edge theories, let me bring this back to you, back to your life, back to why this matters for how you understand yourself and your place in reality. Because here's what we've really been talking about this whole time: the nature of connection. You are not separate from the universe. You are not an object sitting in empty space. You are a pattern of energy matter woven into the fabric of space-time, and you curve that fabric by existing. Every atom in your body is telling space-time how to curve, and that curved space-time is telling every other atom in your body how to move. You are a self-consistent pattern of geometry and substance, a localized intensification of the universe's self-awareness. The boundary between you and the universe is conceptual, not physical. Think about what's happening right now as you watch this. Light from your screen is entering your eye's photons following geodesics through the curved space-time created by Earth's mass. Those photons interact with molecules in your retina, triggering electrochemical cascades that propagate through neural networks in your brain, which are themselves arrangements of atoms following geodesics through space-time. Your thoughts, your conscious experience of understanding these ideas, are patterns of electrical and chemical activity moving through curved space-time. The sense of you experiencing this moment is space-time becoming aware of its own curvature. The universe is using the pattern called you to understand itself. You're not watching a video about gravity. You're experiencing gravity, contemplating its own nature. And here's something even more profound. Remember how I said that mass energy curves space-time, and that curvature tells matter how to move? This relationship is reciprocal and immediate. The curvature around you right now is partially caused by you, and you are partially caused by that curvature. There's no temporal gap, no cause and effect sequence. It's a simultaneous, self-consistent solution to the field equations. You and the geometry of space-time around you are defining each other mutually in every moment. This means that in a very real sense, you are creating the structure of reality around you by existing. Not metaphorically, literally, the equations demand it. Your mass energy is contributing to the curvature field, which is affecting the paths of other objects, which are affecting you. You're part of a vast, interconnected web of mutual causation spanning the entire universe. Now think about this in terms of time. I said earlier that you're falling through time, not space. Let me expand on that because it's crucial to understanding your actual experience of reality. In space-time, you're not just a three-dimensional object. You're a four-dimensional world line, a thread extending from your birth to your death through the dimension of time. At this moment, you're experiencing one cross-section of that world line, one now sliding along the thread. But the entire thread exists in space-time as a complete geometric object. Your past and future are as real as your present, just located at different time coordinates. You're not moving through time so much as time is one of the dimensions of your extended self. The you that exists is not the instantaneous you of this moment, but the entire world line from beginning to end. And here's what makes this beautiful. That world line, that four-dimensional tube that is the totality of your existence, is a geodesic through space-time. It's the straightest possible path through the curved geometry created by everything else in the universe. You are not being pushed or pulled through reality. You're following the natural, unforced path that the shape of reality provides. When you feel weight, when you feel gravity, you're feeling the constant acceleration required to deviate from that natural path. The ground is pushing you off your geodesic. In free fall in orbit, or dropped from a plane, you would feel weightless because you'd be following your natural path through space-time. Gravity isn't a force acting on you. Gravity is your natural state, and everything else is deviation from that state. This reframes everything about how you experience the world. When you jump, you're not fighting gravity. You're briefly following your geodesic before the ground accelerates back into you. When you sit in a chair, the chair is constantly accelerating you away from your natural path. You're not at rest right now. You're accelerating upward at 9.8 meters per second squared, constantly pushed by the electromagnetic forces in the chair, preventing you from passing through it. Rest is motion along your world line through curved spacetime. Everything else is forced deviation from rest. This inverts the entire intuitive picture of forces and motion. You're not held to Earth by a force. Earth is preventing you from following the spacetime geometry that you're trying to follow. Now consider relationships between objects, between people. The moon orbits Earth not because Earth is pulling it, but because Earth has curved spacetime, such that the moon's straightest path through that curved geometry is an ellipse in space. The moon is following its geodesic, and that geodesic keeps bringing it back around Earth. It's not trapped, it's following the natural flow of curved spacetime. Similarly, you're held near Earth not by chains, but by the shape of reality. Every object with mass is creating a dimple in spacetime, and those dimples overlap, interact, create complex geometries. You're navigating through a landscape of curvature, created by the collective mass energy of everything in the universe. Every particle contributes. The Andromeda Galaxy, 2.5 million light-years away, is curving the spacetime you're moving through right now. The contribution is infinitesimal, but it's real. You are connected to everything in the universe through the continuous field of spacetime curvature. This is why gravity is universal. It doesn't care about charge, composition, or any intrinsic property except mass energy. Photons and neutrinos and atoms and planets and galaxies all follow geodesics through the same spacetime geometry. We are all swimming in the same ocean of curved geometry, all following paths determined by the collective mass energy distribution of everything that exists. You're not separate from the cosmos. You're one localized feature in a continuous field that extends across the entire observable universe and beyond. When you look up at night and see stars, you're seeing across curved spacetime shaped by the cumulative mass of all the matter between here and there. The light from those stars has followed geodesics through a geometry created by galaxies, nebulae, black holes, dark matter, and yes, you. Your mass contributed infinitesimally to the curvature that guided that starlight's path. You are part of the landscape through which the universe experiences itself. Let's talk about what this means for your intuition about cause and effect, about how things happen in the world. We grow up with a billiard ball model of causation. One thing hits another, transferring force, causing the second thing to move. Cause precedes effect in time. Simple, local, mechanical. But general relativity reveals that causation in the universe is nothing like this. The curvature at any point in spacetime is determined by the mass energy distribution everywhere, across all of space, integrated into a single self-consistent solution to the field equations. You can't point to one piece of matter and say, that's what's causing the curvature here, because the curvature is caused by everything simultaneously. It's holistic, non-local, and mutual. This has strange implications. Imagine a massive star suddenly appears in empty space impossible, but bear with me. According to general relativity, changes in curvature propagate at the speed of light. The gravitational field doesn't update instantaneously everywhere. It takes time for the curvature wave to spread outward. During that propagation, there's a period where distant objects are following geodesics through a spacetime that doesn't yet know about the new star. When the curvature wave arrives, when the information about the new mass reaches them, their geodesics change. They start curving toward where the star appeared. This is causal, yes, but notice what's strange. The curvature wave travels through spacetime, but spacetime is what's changing. The medium of propagation is the thing that's propagating. space-time ripples through itself. This is like saying the ocean can wave without water moving, but in this case, the water is geometry itself. Now consider this in reverse. When you accelerate, when you jump, wave your hand, or move in any way, you send ripples out into space-time that propagate at light speed. Those ripples are carrying information about your motion outward, affecting the geodesics of distant objects infinitesimally. Every action you take literally reshapes the geometry of the universe. The effects are tiny. The gravitational waves from your movements are so weak they'll never be detected. But they're real. You are constantly broadcasting your existence and activity outward as ripples in the geometric fabric of reality. In principle, a sufficiently advanced detector infinitely far away could reconstruct your entire life by analyzing the gravitational waves that your movements sent outward. Your history is encoded in the geometry of spacetime itself, propagating outward at light speed as an expanding sphere of information. You are writing your biography in the curvature of the cosmos. This makes time travel extraordinarily complicated, probably impossible in practice, though not strictly forbidden by the equations. Certain solutions to the Einstein field equations allow closed time-like curves paths through spacetime that loop back on themselves temporally. If you followed such a path, you'd return to your own past. The Dell solution, found by Kurt Gödel in 1949, describes a rotating universe containing closed time-like curves everywhere. The Kerr solution for a rotating black hole contains closed time-like curves inside the inner event horizon. But these situations are extreme, probably unphysical, and even if they exist, the quantum mechanics of particles following closed time-like curves leads to paradoxes and contradictions. Most physicists suspect there's a chronology protection mechanism, some aspect of quantum gravity we don't yet understand, that prevents closed time-like curves from forming in any realistic situation. The universe seems to protect its own causality. But here's what's fascinating. The blocked universe interpretation of relativity suggests that, in some sense, time travel isn't needed because all times already exist. Your past, present, and future are all equally real, just located at different coordinates in the time dimension. The flow of time, your subjective experience of moving from past to future, might be an illusion arising from the way conscious systems process information. The universe itself is timeless, a four-dimensional geometric structure, and time is just the label we give to one of the dimensions. You're not moving through time. You're extended through time, and your consciousness is experiencing different cross-sections of your world line sequentially. Why? We don't know. That's one of the deepest mysteries of consciousness and physics. But if this view is correct, then every moment of your life, every joy, every sorrow, every choice, every consequence exists permanently as part of the timeless geometry of spacetime. You're not just creating ripples that propagate outward in space. You're creating a permanent structure in spacetime that exists forever once it exists at all. Think about what this means for your choices and actions. Every decision you make, every path you take, becomes a permanent feature of the universe's geometry. You're not just living your life, you're constructing your world line. And that world line is as real and permanent as a mountain range, just extended in time rather than space. The shape you give to your world line matters cosmically, not just personally. You are sculpting the geometry of reality itself with every choice, every action, every moment of existence. The question, what should I do with my life, becomes what shape do I want my world line to have in the eternal structure of spacetime? This isn't metaphorical. This is the literal physics of your existence. Now let me connect this to something even more mind-bending, the expansion of the universe. We've talked about how mass curves spacetime locally around planets, stars, black holes. But spacetime can also curve globally on cosmic scales. In 1929, Edwin Hubble discovered that distant galaxies are moving away from us, and the farther away they are, the faster they're receding. This isn't because they're moving through space away from us. It's because space itself is expanding between us and them. The fabric of space-time is stretching. Galaxies are basically sitting still in their local patches of space, but the space between patches is growing. This is curvature on the largest possible scale, the curvature of the entire universe. The equations of general relativity that describe an expanding universe were actually discovered before Hubble's observations. In 1922, Alexander Friedmann found solutions to Einstein's field equations, describing universes that expand or contract over time. Einstein initially rejected these solutions, adding a cosmological constant to his equations to force the universe to be static, because he believed the universe must be eternal and unchanging. When Hubble's observations proved the universe was expanding, Einstein called the cosmological constant his biggest blunder, except it wasn't a blunder at all. In 1998, astronomers discovered that the universe's expansion is accelerating. Something is pushing space apart faster and faster. We call this mysterious something dark energy, and the cosmological constant Einstein invented, now reinterpreted as vacuum energy, is the leading candidate for what dark energy actually is. Here's what this means. Empty space itself has energy. The vacuum isn't empty. It's seething with quantum fluctuations, virtual particles popping in and out of existence. This vacuum energy has negative pressure, and negative pressure in general relativity creates a kind of anti-gravity that pushes space apart. The more space you have, the more vacuum energy exists, which creates more space, which creates more vacuum energy in a runaway feedback loop. This is why the expansion is accelerating. About 68% of the universe's total mass energy is this dark energy. About 27% is dark matter that curves spacetime, but doesn't interact electromagnetically, so we can't see it directly. Only 5% is ordinary matter atoms, stars, planets, you. You are made of the rarest substance in the universe. The vast majority of reality is invisible, detectable only through its gravitational effects on spacetime curvature. This reshapes our entire cosmic story. The universe began 13.8 billion years ago in the Big Bang, not an explosion in space, but an explosion of space itself. Spacetime itself began expanding from an initial singularity where curvature was infinite. In the first fraction of a second, the universe underwent cosmic inflation, expanding faster than light, which is allowed because space itself was expanding, not objects moving through space. Then inflation ended, leaving a hot, dense soup of energy that cooled as space continued expanding. Matter condensed from energy. Atoms formed. Gravity curvature pulled matter together into stars and galaxies. Those stars forged heavier elements in their cores and scattered them across space when they died. Some of those atoms became you. You are made of stardust, but more accurately, you are made of space-time curvature that temporarily took the form of matter that was once inside stars that formed in regions where quantum fluctuations in the early universe created slightly higher density, which curved space-time enough to collapse into the first structures. Your origin story is the curvature of space-time itself. You began as a quantum fluctuation 13.8 billion years ago, amplified by cosmic inflation, collapsed by gravity into structures, processed through stellar fusion, scattered by supernova, and eventually assembled into the pattern of atoms that currently constitutes your body. And that pattern is itself a curvature in space-time, a localized intensification of the universe's self-interaction. You're not in the universe. You're a temporary formation in the universe's geometric structure, like a whirlpool in a river. The water molecules making up the whirlpool are constantly changing, flowing through the pattern, but the pattern persists. Similarly, the atoms in your body are replaced over time, but the pattern, the information structure, the curvature configuration persists and is what you call you. Now here's where this gets existentially profound. The universe is expanding, accelerating, and will continue doing so forever based on current observations. Eventually, trillions of years from now, all galaxies, except those gravitationally bound to us, will have receded beyond the cosmic horizon, moving away faster than light. The observable universe will shrink to just our local galactic cluster. Stars will exhaust their fuel and die. No new stars will form once gas is depleted. The universe will enter the degenerate era, populated only by dead stellar remnants, white dwarfs, neutron stars, black holes. Even these will eventually decay or evaporate. Black holes will evaporate via Hawking radiation over unimaginably long timescales. Eventually, perhaps 10 to the 100 years from now, the universe will reach a state of maximum entropy, the heat death. No gradients, no structure, no change. Just a cold, dark, uniform bath of radiation in ever-expanding space. This sounds depressing, but here's the reframing. You exist now in the brief, precious window of cosmic history where complexity is possible, where stars shine, where planets form, where life emerges, where consciousness arises. The universe spent 13.8 billion years creating the conditions for your existence. You are astronomically improbable, existing in the tiny sliver of space and time where the temperature is right, where atoms can form stable structures, where chemistry is complex enough for biology, where evolution has time to produce consciousness. You're a miracle of curvature, a self-aware pattern in the geometric structure of a universe that is mostly empty, mostly cold, mostly dead. The fact that you exist at all, that you're experiencing this moment, understanding these ideas, is the universe achieving something extraordinary against enormous odds. Let's talk about consciousness and observation, because there's a deep connection between how you perceive reality and the curvature of space-time that we haven't fully explored yet. I mentioned earlier that different observers in different states of motion experience time differently. This isn't just theoretical, it's measured constantly. GPS satellites orbit Earth at about 20,000 kilometers altitude, moving at about 14,000 kilometers per hour. At that speed, special relativity predicts their clocks run slower than clocks on Earth's surface by about 7 microseconds per day. But they're also in weaker gravitational field, less space-time curvature, which makes their clocks run faster than Earth's surface clocks by about 45 microseconds per day. The net effect is they run about 38 microseconds per day faster. GPS must correct for this, or the positioning errors would accumulate to kilometers within days. Your phone is constantly correcting for relativity effects to tell you where you are. You're navigating through curved space-time using technology that accounts for that curvature. But here's what's philosophically deep. What you experience as now is not what someone moving relative to you experiences as now. Simultaneity, the notion that two events happen at the same time, is relative, not absolute. Events that are simultaneous for you might not be simultaneous for someone moving at a different velocity. There is no universal now extending across space. The present moment is observer-dependent. This means that the division of space-time into past, present, and future is subjective, not objective. The objective reality is the four-dimensional block of space-time where all events exist. Your conscious experience carves that block into a sequence of present moments, but that sequence is unique to your world line. Think about what this means when you look at a star 100 light years away. The light you're seeing left that star 100 years ago. You're seeing the star's past. But from the star's reference frame, if we imagine an observer at rest relative to the star, you haven't seen that light yet. It's still traveling toward you. Different observers disagree about what has already happened and what hasn't. The universe doesn't have an objective temporal structure that everyone experiences the same way. Time is woven into space, and the weaving looks different from different perspectives. Your consciousness stitches together a narrative timeline from your particular path through space-time. But that narrative is one of countless equally valid narratives being constructed by every observer following every possible world line. This raises a deep question. What is consciousness doing? Why does it feel like you're moving through time when, from the block universe perspective, you're spatially extended through time? One possibility is that consciousness is an information integration process that necessarily experiences temporal sequence, because that's how information processing works. Your brain is constantly receiving input, updating models, making predictions, forming memories. This process has inherent temporal structure. Input now affects states later. The subjective experience of time flowing might be the interior perspective on this information integration process. You feel time passing because your consciousness is computational, and computation has temporal order. But here's a wilder possibility. What if consciousness is actually fundamental to how spacetime curvature is actualized? In quantum mechanics, systems exist in superpositions of multiple states until measured, at which point the wave function collapses into one definite state. Some interpretations suggest consciousness is what causes collapse, that observation by a conscious entity is what actualizes reality from quantum potentiality. If this is true, then spacetime curvature, which at quantum scales should involve superpositions of different geometries, might be actualized by conscious observation. You're not just observing curved spacetime. You might be participating in making its curvature definite. This is highly speculative and controversial, but it's taken seriously by some physicists exploring quantum gravity and consciousness. Roger Penrose has proposed that consciousness arises from quantum processes in brain microtubules that somehow access quantum gravitational effects, the OR theory. The idea is that consciousness involves quantum superpositions of space-time geometries in the brain lasting until gravitational self-energy reaches a threshold, triggering collapse and creating moments of conscious experience. If true, your thoughts are literally fluctuations in space-time geometry. Your inner mental life is curvature computing itself. The gap between mind and matter dissolves completely. They're both expressions of geometric information structure in quantum spacetime. You're not in spacetime experiencing it. You are spacetime experiencing itself through a particularly complex pattern of its own curvature. Now let me bring up something that will really test your intuition: the holographic principle. We touched on this briefly with black holes, but it goes much deeper. The holographic principle suggests that all the information contained in a volume of space can be encoded on the boundary of that volume, specifically on an area measured in Planck units. This came from studying black hole thermodynamics. Jacob Bekenstein and Stephen Hawking showed that a black hole's entropy, the information content, is proportional to the area of its event horizon, not its volume. This is weird because normally we think of information as filling volumes. A book contains information spread through its three-dimensional structure, but a black hole's information is proportional to a two-dimensional surface area. This suggests something radical. Our three-dimensional reality might be a holographic projection from information encoded on a two-dimensional surface. The universe might have one less dimension than it appears to have. The real physics happens on a distant boundary, and everything we experience, including depth, volume, and three-dimensional space, emerges from that lower-dimensional information structure. Juan Maldaceni's A-D-CEF-T correspondence, discovered in 1997, proved this mathematically for certain space-time geometries. A gravitational theory in d-dimensional space is exactly equivalent to a quantum field theory on the d1-dimensional boundary. They're the same theory, just described in different languages. Gravity and curvature emerge from boundary quantum mechanics. If this applies to our universe, and it's not yet proven that it does, then space-time curvature isn't fundamental. It's emergent from quantum information entanglement patterns on the cosmic horizon. The curvature you experience, the gravity you feel, might be arising from the way information is encoded and processed on a distant two-dimensional surface. You're a pattern in a hologram. Your three-dimensional experience of depth in space is an illusion arising from lower-dimensional information dynamics. This doesn't make your experience less real. It just means reality has a different fundamental structure than it appears to have. The question, what causes gravity to curve, might be answered by gravity and curvature emerge from quantum entanglement entropy on the holographic boundary. The cause isn't local. It's non-local information structure on the universe's edge. Let's return to the human scale and talk about what all this means for how you live your life. We've journeyed from the mathematics of curvature to black holes, to cosmic expansion, to the holographic principle. But the most important question might be, so what? How does understanding that gravity is space-time curvature change how you exist day to day? Let me suggest several ways this knowledge transforms your relationship with reality. First, it obliterates the illusion of separation. You are not a separate object in space. You are a configuration of space-time itself, connected to everything through the continuous field of curvature. When you interact with another person, you're not two separate things coming into contact. You're two patterns in the same underlying geometric field recognizing each other. Connection isn't something you create. It's something you are. Second, it reframes struggle and resistance. When you feel stuck, when life feels hard, when gravity feels like it's pulling you down, that's literally true. But remember what gravity is. It's not a force oppressing you. It's the natural geometry of reality, shaped by everything that exists. You're trying to follow your geodesic through curved spacetime, and various things, the ground, your chair, social pressures, psychological patterns, are preventing you from following that natural path. The experience of effort is the experience of being accelerated away from your natural motion through reality. Sometimes that's necessary. Sometimes the ground needs to push on you to keep you alive. But sometimes you're being pushed away from your geodesic unnecessarily by habits or beliefs or societal structures that aren't serving you. Learning to distinguish between necessary and unnecessary acceleration, between genuine constraints and self-imposed limitations, is part of wisdom. Third, it illuminates impermanence and change. We've seen that space-time itself is dynamic expanding, rippling with gravitational waves, constantly changing its geometry in response to mass energy flows. Nothing is static. Your body is replacing atoms constantly. Your cells are dying and regenerating. Your thoughts and feelings flow through neural configurations that never repeat exactly. You are a temporary standing wave in a dynamic medium. The suffering caused by clinging to permanence, wanting things to stay the same, fearing change comes from misunderstanding your actual nature. You're not a thing that persists through time. You're a process of continuous becoming, a four-dimensional world line, a pattern sustained by constant change. Accepting impermanence isn't pessimistic, it's recognizing the actual physics of existence. Fourth, it reveals that your mass matters literally and figuratively. Every kilogram of your body is curving space-time. You are affecting the geometry of reality just by existing. This isn't metaphorical weight or burden, it's actual geometric influence. And while your influence on the large-scale curvature is tiny, it's real and permanent. The gravitational waves you create propagate forever outward. Your world line is a permanent feature of the block universe. You matter not because someone grants you worth or because you achieve something, but because you exist, and existence itself is participation in the geometric structure of reality. You're co-creating the universe with every moment of being. Fifth, it suggests that following your nature, your geodesic, is the path of least resistance, not in a lazy sense, but in a profound sense. When you're living authentically, aligned with your deepest values in nature, you're following a natural path through the possibility space of your life. When you're living inauthentically, forced into shapes that don't fit, you're experiencing constant acceleration away from your natural motion. The tension, anxiety, and exhaustion of inauthentic living is like the tension of a chair constantly pushing you away from free fall. Sometimes we need that push, sometimes external structures help us grow. But chronic inauthenticity is chronic acceleration away from your geodesic through life's possibility space. It's exhausting because you're fighting the geometry of who you actually are. Let me share something personal here. When I first truly understood general relativity, not just the equations, but the implications, it changed how I experience being alive. I stopped feeling like a separate observer looking at a universe out there. I started feeling like a temporary intensification of the universe's self-awareness, a localized region where space-time has become complex enough to contemplate its own nature. When I look at stars, I'm not seeing distant objects. I'm seeing across my own extended structure. The space-time connecting me to those stars is as much me as the matter in my body. I'm not in the universe. I am universe, locally condensed into a pattern that can think and feel and wonder. This perspective doesn't diminish the importance of human concerns, relationships, purpose, suffering, joy. If anything, it intensifies them. Because I realize that these experiences are rare, precious, improbable. The universe spent billions of years and countless stellar generations creating the conditions for consciousness to arise. Your capacity to love, to understand, to create, to help others, these are among the most complex phenomena the universe has produced. You are cosmically significant, not despite being small, but because you're the universe achieving self-awareness at local scales. The love you feel for another person is the universe loving itself through your configuration. The understanding you achieve is the universe understanding itself through your pattern of curvature. Now we're going to go even deeper and explore the cutting edge of current research on quantum gravity and what it might reveal about the ultimate nature of space-time curvature. Remember, everything we've discussed so far, general relativity, the Einstein field equations, black holes, gravitational waves, is classical physics. It works beautifully at large scales, but breaks down at tiny scales where quantum effects dominate. The Planck length, 10 to the minus 35 meters, is where quantum effects of gravity become important. At this scale, we expect space-time itself to become quantum, fuzzy, uncertain. But we don't have a complete theory yet. What we have are several promising approaches that might converge on the truth. String theory proposes that fundamental particles are actually tiny vibrating strings, and different vibration modes correspond to different particles. Closed loops of string vibrating in one pattern appear as gravitons, the hypothetical particles that would mediate gravity in a quantum theory. In string theory, gravity emerges naturally as a consequence of string dynamics. But string theory requires extra dimensions, 10 or 11 total dimensions of spacetime, with 6 or 7 curled up so small we can't perceive them. These extra dimensions affect how strings vibrate, which affects which particles and forces appear in our observable four-dimensional spacetime. The geometry of these hidden dimensions determines the physics we experience. In this view, spacetime curvature in our four dimensions is a shadow of geometry in higher dimensional space. The cause of curvature might lie in the shape of dimensions we can't directly observe. Loop quantum gravity takes a different approach. It treats spacetime itself as quantized, made of discrete units called spin networks that evolve over time into structures called spin foams. Space isn't continuous at the Planck scale. It's granular, like pixels. Area and volume come in minimum discrete units. This quantization naturally eliminates the infinities that plague other approaches to quantum gravity. In loop quantum gravity, curvature emerges from how these quantum geometric units can interact. The smooth, continuous spacetime of general relativity is an approximation that emerges at larger scales, like how a digital photograph looks continuous when you zoom out, but is actually made of discrete pixels. This suggests that asking what causes curvature is like asking what causes smoothness in a digital image. The smoothness emerges from averaging over many discrete units. Causal set theory proposes something even more radical, that spacetime is fundamentally discrete, and all that exists is a network of events with causal relationships between them. There is no underlying continuous space or time, just events, and which events can influence which other events. Spacetime geometry emerges from the structure of this causal network. Distance isn't fundamental. Causation is. Two events are close if there are many causal paths connecting them, and far if there are few paths. This turns our intuition inside out. We usually think causation happens across space and time. But in causal set theory, space and time emerge from causal structure. Curvature would be a feature of the network topology. Regions with dense causal connections would appear highly curved. Mass creates curvature by adding events and causal relations to the network in particular patterns. Then there's the entanglement-based approach pioneered by Mark van Ramsdonk and others. This view suggests that space-time geometry, including curvature, emerges from quantum entanglement between degrees of freedom. When quantum systems are entangled, measuring one instantly affects the other regardless of distance. Van Ramsdonk showed that in certain theoretical models, if you reduce the entanglement between regions, the space-time connecting them starts to tear apart. Increase entanglement, and space-time becomes more connected. This suggests the fundamental question isn't what causes curvature, but rather what patterns of quantum information create the illusion of geometric space. Space itself might be emergent from entanglement structure. The distance between two regions might correspond to how hard it is to create entanglement between them. Curvature might reflect information connectivity patterns in underlying quantum networks. What's fascinating is that these seemingly different approaches might all be describing the same underlying reality from different angles. String theory and loop quantum gravity might be complementary descriptions of quantum spacetime. The holographic principle connects to all of them, adds CFT links string theory to quantum field theory. But similar holographic ideas appear in loop quantum gravity and entanglement-based approaches. There's growing suspicion that at the deepest level, information is fundamental. Space, time, matter, energy, and curvature all emerge from how information is organized and processed. The universe might be, at its core, a computational structure, not in the sense of being a simulation, but in the sense that information dynamics are more fundamental than geometric or material descriptions. If this is true, then what causes gravity to curve? Has a surprising answer. Quantum information patterns cause classical geometric curvature to emerge as an approximation describing information connectivity. Gravity isn't fundamental, it's emergent, like temperature emerging from molecular motion. Just as you can't point to a single molecule and ask, what's its temperature? Temperature is a collective property. You might not be able to point to a fundamental entity that causes curvature. Curvature is a collective, emergent description of underlying quantum information geometry. This would mean Einstein's general relativity, despite being our best description of gravity, is describing emergent phenomena rather than fundamental reality. The equations are supremely accurate at accessible scales, but break down at Planck scales because they're trying to describe something emergent as if it were fundamental. Physicist Sean Carroll has suggested that spacetime might be emergent from quantum entanglement in the universal wave function. The entire universe is described by a single quantum state, an inconceivably complex wave function containing all possible configurations. When you zoom in on local subsystems and trace over the rest of the universe, the structure of entanglement between subsystems creates the appearance of spatial relationships and geometric structure. You and I are close in space because the quantum states describing us are highly entangled through environmental interactions. Distant galaxies are far because there's minimal entanglement. Curvature emerges from how entanglement patterns change in response to mass energy configurations. Mass concentrates entanglement in particular ways that we perceive classically as geometric curvature. This is genuinely strange, but potentially profound. It means that when you ask, what causes gravity to curve spacetime? You're asking a question that presupposes spacetime is fundamental. But spacetime might be like wetness, a useful concept describing the collective behavior of water molecules, but not a fundamental property of any single molecule. Similarly, curvature might be a useful concept describing the collective information geometric properties of quantum degrees of freedom, but not a fundamental property of reality itself. The search for what causes curvature might be misguided, like searching for what causes wetness at the atomic level. Wetness emerges from many molecules together. Curvature might emerge from many quantum information units together. This brings us to perhaps the most profound question of all. Why does anything exist? Why is there something rather than nothing? And how does space-time curvature relate to this ultimate question? One approach comes from quantum cosmology, pioneered by Stephen Hawking and James Hartle. They proposed the no-boundary proposal, the idea that the universe's quantum state doesn't have a beginning in time because time itself emerges from the quantum state. In very early universe, before Planck time, the distinction between time and space becomes meaningless. The universe doesn't begin. It simply is, as a timeless quantum superposition. Time emerges as the universe expands and cools, creating an arrow of time from quantum entanglement structure. In this view, asking, what came before the Big Bang, is like asking, what's north of the North Pole? The question assumes time extends indefinitely into the past, but time itself begins with the expanding universe. There's no before, because there's no time before time. The Big Bang isn't an event in time, it's the beginning of time itself, or more precisely, the transition from timeless quantum geometry to classical spacetime with a clear temporal direction. Spacetime curvature emerges from the timeless quantum state as that state evolves into classical geometry. The cause of curvature is the quantum boundary conditions of the universe itself. But we can go even stranger. Some versions of eternal inflation suggest that our universe is one bubble in an eternally inflating multiverse. Quantum fluctuations in the inflattened field, the field driving inflation, create regions where inflation ends and normal Big Bang expansion begins. Each such region becomes a universe with its own low-energy physics, its own effective laws. We inhabit one bubble where the laws happen to allow complexity and life. Most bubbles might be stillborn expanding, so fast that structure never forms, or having different physics where atoms can't exist. We exist in this bubble because this bubble's physics allows existence. This is the anthropic principle. We observe these particular laws because we couldn't exist under different laws. It's selection bias on cosmic scales. In this multiverse picture, space-time curvature in our universe is determined by the quantum state of the inflattened field that nucleated our bubble. Different bubbles have different curvatures, different cosmological constants, different effective physics. The question, why this particular curvature, is answered by, because in the space of all possible bubble universes, this curvature happens to support observers who can ask the question. It's not deeply satisfying philosophically. It replaces why with why not something else? But it might be the right answer. Reality may not have a purpose or deep reason. It might just be the exhaustive exploration of all possibilities, and we find ourselves in one particular possibility because it's the kind that produces minds. Alternatively, some physicists have explored whether the laws of physics could be self-explaining. Lee Smolin proposed cosmological natural selection, the idea that black holes create new universe bubbles with slightly mutated laws. Universes that produce many black holes therefore produce many offspring universes. Over vast timescales, laws that maximize black hole production would dominate. Our universe's laws might be tuned to produce many black holes. Since black holes require stars, and stars require the right balance of forces and constants, this indirectly selects for laws that allow life. It's a Darwinian explanation for fine-tuning without requiring a multiverse or anthropic principle. Max Tegmark has proposed something even more radical, the mathematical universe hypothesis. Every mathematically consistent structure exists physically. Our universe is one such structure. The reason mathematics describes physics so well isn't that math is a useful tool, it's that physical reality is mathematics. The universe doesn't follow mathematical laws. It is a mathematical structure. Spacetime curvature isn't described by the Einstein field equations. It is those equations, or more precisely, it's one solution to those equations manifested as experiential reality. In this view, all possible mathematical structures exist as parallel universes in a level 4 multiverse. We experience this particular mathematical structure because we're patterns within it. The question, why do these laws, becomes why this mathematical structure? And the answer is, all mathematical structures exist. This is just the one we're in. These ideas are highly speculative, sitting at the boundary between physics and philosophy. But they represent serious attempts by serious physicists to answer ultimate questions. And they all suggest that space-time curvature, the phenomenon we've been exploring for 3 hours, is not fundamental. It's emergent, contingent, one possibility among many. The deep truth might be that at the most fundamental level, there is only mathematics, or only quantum information, or only pure possibility space. And from that substrate emerges the rich, complex, beautiful universe of stars and galaxies and black holes and consciousness. You are possibility made actual, information made aware, mathematics contemplating itself. We're in the final stretch now, and I want to bring everything together into a unified vision, a way of understanding what gravity is, what curvature means, and what your place is in this cosmic story. We started with a simple question: what causes gravity to curve? We've journeyed through the Einstein field equations, learned that gravity is curvature, explored black holes and gravitational waves, touched on quantum gravity and the holographic principle, and considered the nature of reality itself. Now let me synthesize all of this into a coherent picture that you can carry with you. Here's the truth as we currently understand it. Reality is made of quantum information structured into patterns. At large scales and low energies, these patterns create the appearance of smooth, continuous space-time with geometric properties. Mass energy configurations create particular patterns in the information structure that we perceive classically as curvature. Objects move along geodesic paths of extremal proper time through this curved geometry. This movement is what we call gravity. But fundamentally, there's no force of gravity and possibly no continuous fabric of spacetime. There's quantum information, entanglement structure, and emergence of classical geometry from quantum substrate. You, the pattern of information, currently experiencing itself as a human reading. This are a temporary configuration in this vast informational structure. You're highly ordered, far from thermodynamic equilibrium, sustained by constant energy flow from your environment. You're an open system, exchanging matter and energy with surroundings, maintaining a complex pattern through continuous change. Your existence is improbable, but not miraculous. Given enough time and space, the laws of physics inevitably produce complexity, structure, and eventually life and consciousness. You're what the universe does, given the right conditions. You're not an accident or an anomaly. You're an example of what's possible. And here's what makes your existence profound. You're not just complex matter, you're self-aware complex matter. You can contemplate your own nature, understand the laws governing your existence, feel awe at the cosmos that birthed you. This capacity for self-reflection is, as far as we know, rare in the universe. Most matter simply exists, following geodesics unconsciously. You exist consciously, able to appreciate the journey. The universe spent 13.8 billion years creating the conditions for your awareness. Stars had to form, live, die, scatter heavy elements. Planets had to coalesce. Chemistry had to complexify. Evolution had to explore billions of genetic possibilities. Billions of years of unlikely events had to unfold exactly as they did to produce the moment of you reading the sentence. That makes you precious. Not in a sentimental way, but in a physical way. You're a structure of extreme negative entropy high order in a universe trending toward disorder. You're a candle flame of consciousness in the gathering dark. Eventually, entropy wins. The stars go out. Black holes evaporate. The universe reaches heat death. But right now, in this cosmologically brief window, there is light and warmth and structure and awareness. There is you. And you're using this brief window to understand your own nature. That's beautiful. That's perhaps the most beautiful thing the universe has done, created patterns complex enough to understand themselves. So what causes gravity to curve? At the deepest level we currently understand, quantum information patterns in the universal wave function create entanglement structures that emerge as classical spacetime geometry at large scales. Mass energy configurations are patterns in this quantum information that create characteristic curvature in the emergent geometry. Objects follow geodesics through this curved geometry. We call this phenomenon gravity. But really, there's just one interconnected structure quantum information geometry, expressing itself as space, time, matter, energy, and the relationships between them. You're not separate from this structure. You're a particularly complex fold in it, temporarily aware of itself. Now, does this answer satisfy you? Probably not completely, because it pushes the question back to, why does quantum information structure itself this way? Or why these particular laws of quantum mechanics? And those questions might not have answers beyond because these are the laws that exist, or because all possible laws exist in different universes. We might be approaching the limits of explanation. At some point, we reach brute facts, things that simply are without deeper cause. The existence of something rather than nothing might be such a brute fact. Or perhaps there's a deeper level we haven't discovered yet. Perhaps there's an even more fundamental description that makes everything snap into place with elegant inevitability. That's the beauty of science and physics. We're always discovering deeper levels. Newton thought he had the answer with forces and action at a distance. Einstein showed that space and time are more fundamental than forces. Quantum mechanics revealed that reality is probabilistic and observer-dependent at small scales. Quantum gravity will probably reveal that space-time itself is emergent from something deeper. And maybe there's something deeper still, layers all the way down, or perhaps a final layer that explains itself through some beautiful logical necessity we haven't yet glimpsed. But regardless of how deep the explanations go, you exist. Right now, reading this, thinking about curvature and geodesics and quantum information. Your existence is not contingent on having final answers. You are real whether or not we understand the ultimate nature of reality. And your choices matter whether or not the future is determined by initial conditions and laws. Because from your perspective, embedded in time, experiencing each moment sequentially, you have agency. You can decide what to do next. You can choose kindness over cruelty, curiosity over ignorance, growth over stagnation. Those choices shape your world line through the possibility space of your life. They determine what permanent structure you leave in the timeless geometry of the block universe. Let me leave you with a final thought, a way to integrate this understanding into your daily experience. Every morning when you wake up, you're resuming your path through space-time. Your world line continues, extending forward through time, carving a unique trajectory through the curved geometry created by everything that exists. Today, you'll make thousands of small choices. What to eat, what to say, where to direct your attention, how to treat others. Each choice nudges your world line in a particular direction through possibility space. Collectively, these choices create the shape of your life. Think of yourself as an artist working in four-dimensional spacetime, sculpting your world line with each decision. You can't control the curvature of spacetime around you. That's determined by the distribution of mass energy in the universe. You can't change the fact that you're embedded in curved geometry. But you can control how you move through that geometry. You can choose which geodesics to follow within the constraints of your situation. This is freedom, not freedom from constraints, but freedom to navigate meaningfully within constraints. You're not separate from the physics governing everything else. You are physics, locally organized into a pattern capable of making choices that matter. When you interact with another person, recognize that you're two world lines intersecting, two patterns in the same underlying information geometry, briefly influencing each other's paths through spacetime. The conversation you have, the emotions you share, the ideas you exchange, these are real physical interactions shaping both world lines. You're not just exchanging words. You're exchanging information that restructures neural patterns, which are themselves curvature configurations in spacetime. You're literally reshaping each other's geometry through interaction. Kindness isn't just an abstract virtue, it's a choice to reshape another person's trajectory in a positive direction. Harm isn't just immoral, it's a choice to distort another world line in ways that constrain their future possibilities. When you look at the night sky, remember that you're seeing across curved spacetime shaped by billions of galaxies, each containing billions of stars, each star curving the geometry around it. The light from those stars has followed geodesics across millions or billions of light years to reach your eyes. You're receiving information encoded in photons that began their journey before humans existed, before Earth formed, perhaps before the sun ignited. That light is carrying the message, I existed once in that distant region of spacetime. And by seeing it, by absorbing those photons, you're completing a connection across vast distances and times. You're part of the universe's network of information exchange, a node in the cosmic web of causation and awareness. When you feel the weight of your body in a chair, reframe what you're experiencing. You're not being pulled down by a force. You're trying to follow your natural geodesic through curved spacetime, a path that would take you toward Earth's center if nothing prevented it. The chair is accelerating you upward, constantly pushing you off that geodesic. The discomfort you might feel from sitting too long is the physical sensation of sustained acceleration away from your natural path. When you stand up and walk, you're choosing new geodesics, navigating through the curved geometry of your environment. Every step is a negotiation with space-time curvature, a collaboration between your will and the geometric structure of reality. When you make a difficult decision, recognize that you're at a branching point in your world line. Different choices lead to different futures, different paths through possibility space. The anxiety you feel isn't weakness. It's your consciousness grappling with the weight of creating your own geometry. You're experiencing the responsibility of being a self-aware pattern that can shape its own development. The universe isn't telling you which path to take. The geometry gives you constraints, but leaves choices within those constraints. This is what consciousness gives you, the burden and gift of participating actively in creating your own structure rather than passively following deterministic paths. When you experience suffering, loss, pain, disappointment, grief, remember that these experiences are also part of your world line, permanent features of your four-dimensional structure. They're not mistakes to be erased. They're valleys in the landscape of your existence, low points that create contrast with the peaks. A world line that only spiraled upward would be less complete, less rich, less authentic to the full range of what consciousness can experience. Your suffering matters because you matter. The universe is experiencing pain through you. Learning what pain is through your configuration. That doesn't make the pain less real or less difficult. but it situates it within a larger context, where even suffering contributes to the cosmos understanding itself. When you create something, art, ideas, relationships, projects, children, you're sending ripples forward through time. You're creating structures that will influence other world lines long after your own ends. A book you write becomes part of someone else's journey years from now. A kindness you show ripples outward through chains of causation you'll never see. A child you raise becomes a new world line that branches from yours and continues forward, carrying patterns you helped shape. You're not just living your own life. You're contributing to the larger tapestry of civilization, adding threads that weave into future patterns. Your world line intersects countless others, and those intersections create new possibilities that wouldn't exist without you. When you learn something new, like you're doing right now by understanding general relativity and space-time curvature, you're restructuring the information patterns in your brain. You're literally creating new neural connections, new synaptic weights, new architectures of information processing. The you that finishes this video is not the same as the you that started it. Your geometry has changed. You've curved differently in response to the information you've absorbed. This is what growth is: continual restructuring of your internal information geometry in response to interactions with your environment. You're not a static thing moving through time. You're a dynamic process of constant becoming, always reconstructing yourself based on new input. When you rest, when you sleep, when you take time to simply exist without striving, recognize that you're still following your geodesic. You're still part of the cosmic process. Productivity culture might make you feel that rest is waste, that every moment must be optimized for output. But from the physics perspective, there is no waste. You're always moving through time at the speed of light through space-time, 1 second per second through time, adjusted by your motion through space. You can't not participate in existence. Rest is simply a different mode of participation, equally valid, equally real. Your world line during sleep is as much a part of your four-dimensional structure as your world line during your most productive hours. When you face your own mortality, when you contemplate the fact that your world line will end, remember what we've learned about the block universe. From the eternal perspective outside time, your entire world line exists permanently. The moment of your birth and the moment of your death are both coordinates in spacetime, equally real, both existing in the timeless structure. The you reading this sentence exists eternally at these coordinates in spacetime. Earth's surface, October 2025, this moment. That existence is permanent, unchangeable, eternally real. Death doesn't erase you from reality. It simply marks the endpoint of your extension through the time dimension. Your world line is finite but complete, a closed structure with beginning and end, forever etched into the geometry of the universe. This doesn't make death less sad or loss less painful. The subjective experience of time means we lose access to loved ones whose world lines have ended, even though those world lines exist eternally in the block universe. The grief is real because from our embedded temporal perspective, past moments are inaccessible. We can't revisit them, can't experience them again, can only remember them. But perhaps there's comfort in knowing that nothing is truly lost. Every moment of joy, every moment of connection, every moment of love exists permanently in the space-time structure. The universe keeps perfect records. Everything that ever happened is eternally real at its coordinates. Your loved one's world lines are complete, unchangeable, permanent features of reality. They exist timelessly, even as you continue forward through your own world line. We're reaching the end of our journey through space-time curvature, and I want to spend these final minutes bringing everything back to the most personal level. You've learned that gravity isn't a force, but the geometry of reality. You've learned that space-time is curved by mass energy. You've learned that you're following geodesics through this curved geometry. You've learned that space-time might be emergent from quantum information. You've learned that your world line is a permanent four-dimensional structure in the block universe. But what does all this mean for how you walk through the world tomorrow? Here's what I suggest. Live as if you understand that you are not separate from the universe, but a temporary pattern within it. When you feel alone, remember that you're connected to everything through the continuous field of space-time. When you feel insignificant, remember that you're curving the geometry of reality just by existing. When you feel purposeless, remember that you're the universe becoming conscious of itself. When you feel afraid, remember that your world line is already complete in the block universe. And fear is the time-embedded experience of uncertainty about future segments of that world line. When you feel stuck, remember that you're always moving through time at light speed in space-time, always progressing along your world line, always becoming. Make choices that honor the preciousness of consciousness. You're a brief candle flame in the cosmic dark. Use your light. Be curious, continue learning about the universe that created you. Be kind, you have the power to reshape other world lines through your interactions. Be brave, fear is natural, but so is the courage to extend your world line into uncertain futures. Be authentic, your world line is unique, and pretending to be someone else creates dissonance between your choices and your nature. Be present, this moment right now is your current cross-section of your world line, the only place where you can actually experience existence. Be grateful, the probability that you exist at all is astronomically small, and yet here you are, aware, thinking, feeling. Understand that science and spirituality aren't opposed. They're both attempts to understand your relationship with reality. Science gives you the mathematics and mechanisms, the Einstein field equations, quantum mechanics, information theory. Spirituality gives you the subjective meaning, the awe, wonder, and significance of existing. You need both. Knowing that you're a pattern of quantum information doesn't diminish the importance of love, beauty, or purpose. It deepens it. Because now you understand that love is the universe recognizing and valuing itself through your particular configuration. Beauty is the universe appreciating its own structure. Purpose is the universe organizing itself into patterns that achieve goals. These experiences aren't illusions to be dispelled by physics. They're the interior subjective reality that corresponds to the exterior objective description physics provides. Realize that uncertainty is fundamental, not just to quantum mechanics, but to existence itself. You can't know the future precisely. You can't control all variables. You can't predict how your choices will ripple through the vast web of causation. And that's okay. That's necessary. Determinism and uncertainty are both true at different levels of description. The universe might be deterministic at the fundamental level, the quantum state evolving according to the Schrödinger equation. But from your embedded perspective, with limited information and computational capacity, the future is genuinely uncertain. This uncertainty creates the space for agency, choice, and meaning. If you knew the future perfectly, choices would be meaningless. Uncertainty makes your decisions real. Practice seeing the extraordinary in the ordinary. Every mundane moment involves staggering complexity. Right now, trillions of atoms in your body are vibrating. Electrons are orbiting nuclei. Chemical reactions are cascading through cells. Neurons are firing in intricate patterns, all following the laws of quantum mechanics and curved spacetime. You're breathing air molecules that have been inside countless other organisms, that were perhaps breathed by dinosaurs, by ancient humans, by trees that no longer exist. You're made of atoms forged in stellar cores that exploded billions of years ago. Your consciousness is billions of neurons coordinating through electrochemical signals, creating the unified experience of being you. The fact that any of this works, that it produces stable patterns and conscious experiences, is miraculous, not because it violates physical law, but because physical law is capable of such richness. Recognize that you're part of an ongoing story. The universe began 13.8 billion years ago in the Big Bang. Inflation stretched tiny quantum fluctuations to cosmic scales. Matter condensed from energy. Gravity pulled matter into stars. Stars fused hydrogen into heavier elements. Supernovas scattered those elements into space. Gravity collected them into new stars and planets. On at least one planet, likely many, chemistry became complex enough for life. Life evolved, eventually producing nervous systems, brains, consciousness. Consciousness developed language, culture, science. Science developed to the point where consciousness could understand the laws governing its own existence. You're the current leading edge of that story. Consciousness sophisticated enough to contemplate spacetime curvature and quantum gravity. You're where the universe has gotten to so far in understanding itself. And the story continues forward. What comes next? Maybe humanity spreads through the solar system, then to nearby stars, becoming a multiplanetary or multistellar civilization. Maybe artificial intelligence develops, creating new forms of consciousness with capabilities far exceeding biological brains. Maybe we solve quantum gravity and unlock new physics that enables technologies we can't currently imagine. Maybe we discover we're not alone, that consciousness has evolved elsewhere too. Maybe we're the first, the universe's initial experiment with self-awareness, responsible for spreading consciousness to the cosmos. Or maybe our species ends, and the universe continues without us, until entropy finally claims everything. We don't know. But right now, in this moment, you're here, conscious, thinking, part of the story. That makes you responsible. Not cosmically responsible. The universe doesn't need you to succeed or fail, but responsible to yourself, to other conscious beings, to the rare and precious phenomenon awareness. You have the capacity to increase or decrease suffering, to create or destroy complexity, to spread understanding or ignorance, to treat other conscious patterns with compassion or cruelty. These choices matter locally, even if they don't matter cosmically. They matter to the beings affected by them. And since those beings are also you patterns in the same underlying information geometry, harming them is harming yourself. Helping them is helping yourself. Not metaphorically, literally. We're all curvatures in the same spacetime, all temporary patterns in the same quantum information structure. So here's my challenge to you as we close. Integrate this understanding into your life. Don't let it remain abstract knowledge. Let it transform how you perceive and interact with reality. When you walk, feel yourself navigating through curved spacetime. When you relate to others, recognize them as fellow world lines intersecting yours. When you choose, understand that you're sculpting your four-dimensional structure. When you suffer, situate it within the larger context of your complete world line. When you experience joy, appreciate it as the universe experiencing joy through you. When you learn, celebrate the restructuring of your information geometry. When you create, recognize that you're sending influences forward through time. When you love, know that you're performing the universe's recognition of its own value. You came to this video asking what causes gravity to curve. I hope you now understand that the question was deeper than it seemed. Gravity doesn't cause curvature. Gravity is curvature. Mass energy doesn't cause space-time to curve. Mass energy and curvature are two aspects of the same phenomenon, related by the Einstein field equations. At the deepest level, quantum information structures itself in patterns that emerge as curved space-time at large scales. The cause isn't separate from the effect. They're inseparable aspects of a single unified reality. And you conscious, curious, capable of understanding this, you're not outside that reality looking in. You're inside it, made of it, an instance of it. Your space-time contemplating its own curvature. The universe spent 13.8 billion years creating you. Billions of years of stellar alchemy, planetary formation, chemical evolution, biological evolution, cultural evolution, all so that right now, at this moment, you could understand your own nature. That's extraordinary. That makes your life meaningful, not because someone externally granted it meaning, but because you are meaning, the universe meaning something to itself. Your existence, your consciousness, your choices, your understanding. These are what the universe does when it gets sufficiently complex. You're not an observer separate from the observed. You're the universe observing itself through the particular configuration of matter and information that constitutes you. So go forward with this knowledge. Let it inform your choices. Let it deepen your experience. Let it connect you more fully to the reality you're embedded in. You're not falling through space under the influence of a mysterious force. You're following the straightest possible path through curved spacetime, participating in the geometric dance of reality. You're not a separate observer in an objective universe. You're a subjective experience arising from an objective information structure, the interior perspective corresponding to a particular pattern in quantum geometry. You're not insignificant cosmic dust. You're the universe's current attempt at self-understanding, localized in this place and time. And that is beautiful. That is profound. That is enough. You don't need external validation or cosmic purpose. You are purpose, the universe, purposing itself through your pattern. You don't need to discover meaning. You are meaning, the universe meaning something to itself through your consciousness. You don't need to find your place in reality. You are reality temporarily organized into a form that can ask questions, seek answers, feel wonder. Thank you for taking this journey with me. Thank you for investing 3.5 hours to understand something deep and true about the nature of existence. Thank you for being curious, for pushing past initial confusion, for staying with difficult concepts until they crystallized into understanding. You've restructured your neural networks today. You've changed your information geometry. You're not the same person who started this video. You've grown, evolved, become more complex and more capable of understanding. That's what consciousness does. Grows toward truth, reaches toward comprehension, expands its capacity to model reality. If this video has changed how you see the world, share it with someone else. Help spread this understanding. We're all in this together, patterns in the same space-time, nodes in the same information network, experiments in the universe's ongoing process of self-discovery. The more of us who understand our true nature, the better we can navigate the complex geometry of reality together. Drop a comment sharing your thoughts, your questions, your own insights. Subscribe if you want more deep dives into the nature of reality. Like this video if it resonated with you. And most importantly, go live your life with this new understanding, following your geodesic through curved spacetime with intention, awareness, and appreciation for the extraordinary improbability and preciousness of your existence. You are the universe, conscious of itself, for a brief and beautiful moment. Make that moment count. Not because you have to, not because there's cosmic judgment or external purpose, but because you can. Because consciousness gives you the capacity to choose meaning, create beauty, reduce suffering, and increase understanding. That capacity is the universe's gift to itself through you. Use it well. This is where our journey ends. But your journey continues, forward through time, along your world line, carving your unique path through the curved geometry of reality. Every moment from now on, you'll see the world slightly differently. Gravity won't be a force pulling you down, but the shape of space-time guiding your motion. The ground won't be still, but accelerating upward. The stars won't be distant objects, but coordinates in your extended space-time structure. Other people won't be separate entities, but fellow patterns in the same underlying field. And you won't be a small, insignificant speck, but a precious, improbable, beautiful configuration of the universe experiencing itself. Go be that. Be conscious. Be curious. Be kind. Be authentically yourself. Follow your geodesic with courage and wonder. And remember, you're not just in the universe. You are the universe, looking at itself through your eyes, thinking about itself through your mind, feeling itself through your heart. That's what causes gravity to curve. That's what you are. That's the answer. Thank you for watching. Now go curve space-time with intention.